So we are back with 6.2.3. In this one, they say to us in the 6.2.3, they say calculate the equilibrium constant, calculate the Kc value at the new temperature. We said this is the table that will be start by doing it. Remember, in the table like this one, you will get 4 marks in this case. We are on the table to say the question now, as you can check, is 8 marks. Calculate the equilibrium constant. Already I've got 4 marks in this case after drawing the table to say that is the table which is for 6.2.3. Now, if a learner can make a change in both reactants, you get 1 mark. The change in the products, you get 1 mark, that's 2 marks. And if you can now apply the ratio correctly, you get 1 mark. If you can divide all equilibrium moles by the volume, you get another mark. So already we've got 4 out of 8 in this case. Then now let's go and find the Kc value. What you do, you have to write the Kc expression first. The Kc expression for this, which will be a mark as well, it will be now the concentration of PQ squared divided by the concentration of P squared multiplied by Q2 squared, Q2, sorry. Then according to the table here, the equilibrium concentration of PQ is 1,4, then squared, we change the bracket, in this case, divide by, and then the reactants are 2, then we have got P, which is 0,6 squared, and then we have got Q2, which is 0,5. If you use your calculator in this case, you will get the Kc to be 10,89, which doesn't have any value. Then that's how the marks will be allocated, hopefully. In this case, the learner will be given the 5th mark on this one, and then 1 mark for the Kc, 1 mark for substitution, 1 mark for this. Therefore, you get 8 out of 8 in this one. Very important to know the principle of the table, know how to move from the initial to final. If you know how to move from initial to final in both reactants, you get 1 mark for that. If you know how to move from initial moles to the final moles in the products, also you get another mark. The ratio, the numbers doesn't have to be correct. As long as you follow the 2:1:2, you get awarded a mark there. And then whatever that you find at equilibrium, please consider the volume, which is 2 decimeter cube. You divide everything here by 2. Even if the answers are incorrect, you will still award 1 mark for the principle. Then the Kc expression has to be correct. If you substitute those values that are at equilibrium, which are incorrect, and in the correct Kc expression, you get 1 mark. You lose only the 1 mark for the answer. In that case, that's how we allocate marks in the Kc. Now the next question here, which is 6.2.4, they say to us, how will the equilibrium constant calculated in question 6.2.3 be affected when the volume of the container is decreased at constant temperature? As long as the temperature is constant, then they say choose from increase, decrease, or remains the same, and give reason. As long as the temperature remains constant, therefore Kc will remain the same. Remains because only change in the temperature affect the value of Kc. The reason will be only temperature change. Only temperature change affect the Kc value, or just to say the temperature remains constant, or just to say change in pressure in this case has no effect on the Kc. So that is the reason. 6.3, they're saying to us more Q2 is now added into the reaction mixture at constant temperature. We are now, in a nutshell, we are increasing the concentration of Q2. Q2 is a reactant. How will each of the following be affected? Choose increase, decrease, or remains the same. 6.3.1, they are saying to us, how will the yield of 2P be affected? Once you add one of the reactants, according to Le Chatelier's principle, the reaction that is going to use the increased concentration is favored, which is the forward reaction. Therefore, the amount of P and Q2 will decrease, whereas the amount of PQ will increase. Therefore, the answer will say increases. Increases. 6.3.2, they say the number of moles of P. What will happen to the number of moles of P? P is a reactant. We say once you increase one of the reactants, the forward direction will be favored. Therefore, both P and Q will decrease. Then you will find, if this is in a graph, you will be finding, let's say P was this, and then Q was this, Q2 was this one. At this point, we increase the concentration, then this will happen. That's the case. So both Q2 and P will decrease. Therefore, it means that now the answer here, we just tell the examiner, I know it will decreases. That is the last answer to get the 18 marks out of this question. I hope you learned a lot, also in terms of Le Chatelier's principles explanation, and also in terms of the Kc table, also in terms of the definition, and also the Kc expression. How do you write that, and how do you interpret this type of a graph again, whereby now we say we have got Q, and then Q goes up. Then, according to Le Chatelier, the direction that is going to use the increased concentration is favored, which is the forward. Therefore, the Q2 will decrease, and also P will decrease. Not P2, P will decrease. So both of them will go down, will decrease as the product, as the reactants, and then the product. If we had at equilibrium now having the PQ, this one being PQ, therefore its concentration was going to increase. So PQ will increase. That's what is going to happen at equilibrium in this case. Thanks a lot. I hope you learned a lot out of this one. Thank you. Keep well.